Rules of probability. Multiplication. Independent events. Events are independent if the occurrence of one has no effect on the occurrence of other events. The probability of independent events is the product of the probability of individual events. A coin and a die are thrown. Find the probability of getting a 5 in the die and tail on the coin. If we see the chart, we have 12 possible results because we have 6 options on the die and 2 options on the coin. That is that we can have 1 with head or tails, 2 with head of tails, and so on. In this case, there is only one way to obtain a 5 and a tail. That will be 1 out of 12. If we use the rule, we will have that the probability of getting a 5 in the die, that is 1 out of 6. And getting a tail on a coin, that will be 1 out of 2. Now we apply the rule of the multiplication, getting a 5 on a tail on the die and a tail on the coin, that will be 1 over 6 multiplied by 1 over 2, that will be 1 over 12. Let's see the following sample. In a box there are 4 white balls and 5 blue balls. A. If a ball is taken and returned, then another ball is taken. What is the probability that both are blue? That is, we're going to pick one ball and put it back. So the total number of balls is not affected. We will have the same 9 balls. So that is, the first ball is blue and the second ball also is blue. So that is, how many blue balls do we have? We have 5 blue balls out of 9. That is the first time that we pick a ball. Then we put it back, and the second time we also have 5 blue balls out of 9. And we're going to apply the multiplication rule. 5 that multiplies 5 will be 25, and 9 that multiplies 9 will be 81. Now the second case, we pick a ball and we keep it. What is the probability that the first ball is blue? That is 5 out of 9. The second ball also, what will be the probability that it's blue? Because we keep one ball, we assume that that ball was blue. That is, now the favorable result will be 4 out of 8 because we keep one ball. And then we multiply each event. That will be 5 that multiplies 4, that will be 20. 9 that multiplies 8, that will 72. We must simplify the fraction and we will get the final result. Lesson number 4, conditional probability. Conditional probability is the probability that a particular event happens given or knowing that another event have occurred. Let's see. Probability of event A knowing that event B already happened, or that means that we know the result of the event B, and is calculated as the intersection of both events divided by the known event. Probability of B knowing event A. If you notice, the known event is at the right and it's at the lower part of the fraction. If you see event B, it's at the lower part. Event A is at the lower part. That is the event that is at the right. Let's see the following sample. Two dice are tossed, one white and one black. What is the probability that the sum gives us a number greater than 6, knowing that the result of the black die was a number fewer than 3? First, if we check, the addition will give us a number greater than 6. We have all these results in here. If we count them, we will have 21 results out of 36. We know that on the black die we got a result less than 3, and it's in here. And we will have 12 out of 36. Now we check the intersection in both events, and we have 3 out of 36. The known event is B, and it's placed at the lower part. Okay? Intersection. If we solve it, we write first the intersection. We have 3 out of 36. The known event is B. We have it in here. 12 out of 36. If we solve it, we will have 3 out of 12. Is the part we have it in here with blue. 3 results, or 3 possible results out of 12, because we know that on the black die we have a number less than 3. That will be the result. If we simplify the fraction, we will have 1 out of 4, and that will be the result. Let's check the following sample. In a school with 400 students, 250 pass math and 200 pass physics, and 80 students pass both subjects. If a student is chosen at random, what is the probability that passed math knowing that had passed physics? In this case, we are going to start by the intersection. We place 80 students pass both subjects. Now we can complete it, the student that had passed math or physics. In this case, we will start with the people that pass physics. We already have 80 students. We need to complete 200. So we place 120 plus 80. We will get 200 students that pass physics. The same procedure, we will apply it with the students with pass math. We will have 170 plus the 80, we will have 250. If we add these numbers, we will have 120 plus 80, that will be 200, plus 107, that will be, and 70, sorry, that will be 370. We are missing 30 students out of 100. Those 13 students means that fail both subjects. Okay, now continue with the question. What is the probability that he or she has passed math knowing that he has or she has passed physics? Physics is the knowing event, so that will be placed at the right. The knowing event is at the lower part, and in here we take all the students, the 200. And we have the intersection in here, the part that is common in both events. 80 out of 400 divided by 200 divided by 100. If we solve it, we will have 80 out of 200. If we simplify the fraction, we will have 8 out of 20, and we can simplify it. We will have 4 out of 5, and that will be the result. 4 over 5. We can leave it like as a fraction, we can write it as a decimal or as a percent. Let's see another example. Here we need to be careful with the sentence. We have in a school there are 65 students, of which 30 only like tennis, 20 only like baseball, and 15 like both. In this case we can start by the intersection or by the people that likes the sport, because the simple word only. 30 people only like tennis, 20 people only like baseball, and 15 people like both. If we select a student at random, what is the probability that he likes tennis if we know he likes baseball? So the known event, we place it to the right, and the probability of that event, we will write it as a lower part of the fraction. So the intersection will be 15 out of 65, and the known event will be 35 out of 65. If we solve the division, we will have 15 out of 35, and we can simplify the fraction, and that will be the result.